Hello to all of you and welcome back to my SP2 channel. So this video is all about the electron configurations. We're going to be looking at introduction for sure. They're going to be definitely a look at the periodic table, and I also have a practice for you at the end. Okay, so if you think about how they actually build the periodic table, it is going to be based on the three fundamental rules that govern the arrangements of the electrons in atoms. And those are going to be the Aufbau principle, Pauli exclusion principle, and we also have Horn's rule. So the next few slides, we're going to be covering these three principles together. Okay. Okay, so starting by your first principle, which is Aufbau principle. So thinking about your atomic orbitals, right? If you try to add the electrons in your atomic orbitals, it must be in the order of increasing the energy. You start from the lowest one, right, that is available, and then you can add more and more as you progress. There are going to be a couple of key features, right? Starting by the first one, it says as the n increases, the energy of the orbitals are going to increase, right? Which makes sense. The second one is all about having a bunch of different orbitals, but they have the same principal quantum number, right? So if they have the same principal quantum number, which is the n, then they're going to have the same energy level. Okay. Additionally, as the shape of the orbital becomes more complicated, the energy of these orbitals are also going to increase. Okay, cool. Okay, so the second one is our Pauli exclusion principle. According to this principle, no two electrons in an atom can have the same set of four quantum numbers. Okay, hold on. I thought we only have three quantum numbers, which was covered in our previous lecture. Yes, you're right. There's another one, which is a new one, right? And that is going to be our spin magnetic quantum number. And it goes by the MS. And there are only two allowed values for this new quantum number, which is either positive half or negative half. Okay. You can think about the positive one as the spin up and the negative one is a spin down, right? And in order to have them stabilize, right, the two electrons in a same orbital, they need to have opposite spin, okay? So because there are only two options for the MS, we can conclude that for an orbital, we're going to have the maximum of two electrons, and they should always have opposite spins, right? Okay, excellent. Okay, so the third one is Horn's rule, and this one states that when filling degenerate orbitals means that we have same energy level, the lowest energy is always attained when the number of electrons having the same spin is maximized. Okay, so what does that mean? This means that when you try to add electrons to your degenerate orbitals, you try to fill them singly first before you pairing them up, right? This would help to minimize the repulsion between the two electrons and therefore maximize the stability of them. Okay, so for example, for p, d, or f orbitals, where we have, a number of degenerate orbitals, the electrons must be spreading out before we pair them up. Okay, excellent. Okay, so now we are ready to talk about the electron configurations, which is referring to the arrangements of the electrons in an atom's orbitals according to these three rules that we just covered them. It describes how electrons are distributed among different energy levels, which is your shells, right? As well as your subshells, and those are your s, p, d, and f orbitals. We're going to use the periodic table all the time, right, to express the electron configuration of each element. So there's nothing to memorize. It's more about referring to the table, right? And we're going to have a lot of practice together. Okay, so let's take a look at the periodic table. Just a quick reminder, I have covered all of the details about the metals and non-metals for the periodic table on the second lecture on chapter 1. And I will link it down here just in case that you want to have another quick look to that, right, kind of reminder. Because on this page, we're going to be focusing more on the, orbitals and the electron configurations, okay? So as you can see, everything is nicely color-coded here. So what I have for you is on the left side, you've got your s orbitals. You can call that the s block, right? And then I have the f orbitals or the f block metals. You've got your d orbitals, right, your transition metals, and we also have the p orbitals, right, which is far right of the table. Okay, now if you're thinking about the length of this table, it's going to be too big, and that means it's not going to be easy to fit them in a regular size of our pages, right? And that's why it's a very good idea to have your F block kind of separated, and you can put that at the bottom of the table. Okay, so that's the only reason that we have this slight rearrangement in our blocks. Okay, the second thing that I want to have everybody's attention is take a look at your sixth row, right? Your sixth shell, where we have the 6s orbital. After your 6f, when you, or sorry, 6s, when you're looking at the f um, electrons, they're going to be starting from 4f. Okay. Now, if you ask me why, the answer is going to be a lot more complicated, and it will take forever for me to explain that. So I want to ask you guys to take it as a fact, okay? And just know it and make sure that you are always paying attention to have 2 rows down for your F block, right? And then when you're looking at your D, you're going to have actually 1 row down. So it is 6s, but you're looking at your 5d, right? And then you're going to be back to your normal p, which is going to be 6p, okay? So when we do the practice, you get more of these kind of exceptions, okay? Excellent. Okay, so here is the periodic table, right? You already have seen that. You've got all the elements with the number of electrons, protons, right? So this would be our reference. Anytime that we have a question about the electron configuration, this would be our reference. We always need to look at the table to write down the electron configurations, okay? So I'm going to have one practice for you. Follow me on the next page. I'm going to go over just one example in this video, which is for carbon. And then the next video will be covering a lot more practice, right? Like focusing on the electron configurations, okay? So this example is about, or this question is about carbon. If you look at your carbon, which is over here, we have 6 electrons, okay? So I'm going to start by 1s2, which is my first orbital, where we have 2 electrons. The next one is going to be 2s1, 2s2, right? And then I have 2p1, 2p2, and I can stop here, right? So when you try to write it, bear with me, it's going to be my carbon, right? Where we have 1s2. So the number of electron is going to become your exponent here. And then I have 2s2. And then I have 2p2. And that is perfect, right? Now, when you're thinking about all of these elements, it is very likely to have so many electrons. So it's a little bit tedious, right, if you want to write every single orbital. So we have a kind of shortcut for you, okay? So when you're thinking of the electrons, either we can call them valence electrons, and those are the ones that they have the highest n number, the principal quantum number, and everything else is going to be your core electrons. So that means for the carbon case, these are going to be my core electrons, 1s2. And they actually going to be presented by the noble gas in the previous row, which is your helium. So I can write this down as helium, right? And I have this square bracket around it. That means I'm done with all the core electrons. And then I can continue with my remaining electrons, which are going to be your valence electrons, okay? I promise you there's going to be a lot more practice covering on the next video. Okay, so let's just close this video for now. Thank you very much, everybody, for watching this video. If you like it, give it a thumbs up. If you have any questions, you can always comment below. I always would love to hear from you guys. Thank you for supporting my channel. I'll see you soon on the next video. Bye-bye for now.